students, now let's take one more question which is based on the concept of shift of origin. Now, if you observe in this particular question, you can make use of both the concepts, the shift of origin as well as the regular way of solving the problem. Now, obviously, I'm going to make use of the shift of origin because it always makes the question more convenient. Observe carefully. You can see the x-axis and the y-axis. There is some part of the shaded region lying in the first quadrant, some part is in the second quadrant, and some part is in the fourth quadrant. There is no shape, no part of the standard part, or you can say no standard shape of this composite shape lies in the third quadrant. So there is nothing in the third quadrant, first, second and fourth quadrant. So the entire composite shape is lying in the first, second and fourth quadrant itself. So it becomes very easy if I take the entire diagram only in the first quadrant, isn't it? So I'm going to shift the origin so you can easily understand that if I want to keep the entire plane lamina in the first quadrant, I should take the horizontal x-axis over here parallel to the original x-axis, isn't it? Passing through this corner, and the y-axis can be taken parallel to this y-axis over here passing through this extreme corner. So students, I'm going to select my x and the y-axis accordingly so that my entire plane lamina lies in the first quadrant itself. So observe carefully. This is where I'm going to take the x-axis. Getting on? So that's capital X. Isn't it? Make sure that you are now using the capital letters, and this line is going to become the y-axis. So let's draw this line. This is your y-axis, isn't it? This is small o, the origin. So I'll represent it with a small letter O. This is capital O, the new origin. So again, students, you got to remember when you're doing the shift of origin, you're going to write the old coordinates of the new origin. The new coordinates of the new origin are definitely going to be 0, 0, but the old coordinates, you need to take care of that. So let's begin with the concept over here. I need to first of all find the centroids of all the standard shapes. You can easily understand that out of a very big square, it's going to be a square. Look at this. This is a quarter circle. This part is a quarter circle. So you had a square. From that you have cut out a quarter circle. You removed a quarter circle, isn't it? A quarter circle is removed. It has radius A. So you can easily understand that this length is also A, isn't it? Whereas you can observe here also there is a quarter circle. It is again removed from a square plate, isn't it? So that's radius A, that's radius A. So this length is also going to be small a. So the total length becomes 2a here. This length also becomes 2a. So this is a square. From this very big square, I'm going to remove 3 quarter circles. 1, 2 and 3. The 3 quarter circles need to be removed. So the areas of the 3 quarter circles is going to be negative, isn't it? Areas of the 3 quarter circle is going to be negative, and area of the big square is going to be positive. So let's begin now, students. The very first standard shape, the very big square. So now from this very big square, I need to not just remove the 3 quarter circles, but I also want to remove this entire square plate, isn't it? This also needs to be removed. So in all, there are 5 standard shapes that I want to think of here. A very big square, the 3 quarter circles, and a small square plate, isn't it? So now let's begin with the very first diagram, which is a very big square. So I'm going to take here the first diagram, which is a square, isn't it? So I take the x and the y-axis. This is the x-axis. This is the y-axis. Now you take this square over here. What is the dimension of this square? It is going to be 2a and 2a, isn't it? 2a and 2a. So this is a square of side 2a. So I take a square. Its side is 2a. Now I know that a square is a symmetric shape, isn't it? You can draw the lines of symmetry over here. So this is one of the line of symmetry. This is the other line of symmetry. The intersection of the line of symmetry is going to be the centroid. So I'm going to call it as G1. It's a distance. Now remember, this is not small x and small y. It is capital X and capital Y. You've got to be very careful with all these things, students. So these are with respect to the new x and the y axis. So that's capital X and capital Y. So you have this x1 bar and then you will have this y1 bar. Getting or not? So this is the origin, capital O. So x1 bar, y1 bar, 2a, 2a. So you can easily tell that this length is going to be a. X1 bar is a, y1 bar is also a. The entire plane lamina now lies in the first quadrant, isn't it? The entire plane lamina, since it is lying in the first quadrant, you can easily identify that the coordinates, x coordinate, y coordinate for all the particular standard shapes are going to be positive. So here, let's first of all write the area. So students, area A1 is going to be 2a square. So that simply becomes 4a square, isn't it? Square units. So let's not make use of the dimensions over here. Let us keep it as it is. That's 4a square. Then let's write x1 bar. It is going to be, this length is 2a, half of it, that's a. So I simply write a, and y1 bar is also going to be a. So that was all about the very first diagram, the very big square. Let's take the second simpler diagram, which is again a square, but this time the sides are a and a. So here I will take the second diagram, also a square. Isn't it? Let's take the second diagram, which is also a square. Here I take the smaller square, isn't it? So now the dimensions are a and a. So I have the x-axis, I have the y-axis, and again there is a square, but this time the length of the side is a. So this is a, this is a. Again you will have the lines of symmetry. So draw the lines of symmetry. They will intersect at the centroid. So that's G2, isn't it? And its distance. So that's x2 bar, and that's y2 bar. Getting on also x2 bar and y2 bar you have. So here you can say the area A2 is going to be a square. Very simple, because the side this time is a. Then you want to write x2 bar. So x2 bar is going to be careful this time, the length of the side is a. So therefore this x2 bar is going to be a upon 2, and y2 bar is also going to be a upon 2. So I've got x2 bar and y2 bar. So that was for the smaller square. So I've taken the very big square, I've taken the smaller square. Now let's take all the three quarter circles one by one. Be very careful when you draw the quarter circles. You should be drawing them at the exact same position where they lie with respect to the x and the y axis. So let's begin with this very first quarter circle, isn't it? So this is the first quarter circle that I'm going to consider, isn't it? This first quarter circle I need to consider. So let's shade it out. Let us make it distinguishable over there. So this is the quarter circle, the first one, isn't it? I want to place it at what distance? A from the y-axis, and one of its radius is directly on the x-axis. So I take the very first quarter circle. So third one, I take quarter circle. The quarter circle, isn't it? The very first quarter circle. This is the x-axis. Again, be very careful students. You got to take capital X and capital Y. So that's the x-axis. That's the y-axis. Observe carefully where the quarter circle is placed, isn't it? It is at a distance of a. Getting or not? This is one of the radius, and the other radius you can see here. So let's draw the quarter circle here. This is your quarter circle, isn't it? What is the distance of the quarter circle from the y-axis? This distance is a. So I write here a. Observe very carefully. Now I know that the centroid of the quarter circle is definitely at a distance of 4r upon 3 pi from the two radii of the quarter circle. So let's draw two lines such that from the radii the distance must be how much? It should be 4r upon 3 pi. Be very careful. This distance must be how much? 4r upon 3 pi. This is the centroid. This is G3. Getting or not? This is G3. Now you remember, you want to tell the coordinates of the centroid with respect to the original x and the y axis. So the distance from the y axis becomes the x coordinate, isn't it? The distance from the y axis. So this is the distance from the y axis. So this is going to be x3 bar, and the distance from the x-axis, it is going to be y3 bar, isn't it? So that's x3 bar and that's y3 bar. So observe carefully, look at this x3 bar. X3 bar, if I want to get this x3 bar, tell me what is the total length, students. What is going to be the total length? It is definitely going to be 2a, because this quarter circle has what radius? The radius of the quarter circle is a. So that's a, total length becomes 2a. So what is x3 bar going to become? It is going to become 2a, the total length, minus 4r upon 3 pi. Isn't it? The total length 2a minus 4r upon 3 pi. So here, very first thing, I'm going to write the area. Let's write the area. So I'll write A3. So what's the area here? It is a quarter circle. I know that the area is pi r square upon 4. So I write here pi r square upon 4. What's the radius of the quarter circle? We know it is small a. So it becomes pi a square upon 4. That's the area of the quarter circle. Now, I want to get x3 bar and y3 bar. So x3 bar, you have realized it is going to be the total length, which is 2a minus this 4r upon 3 pi. Isn't it? This distance was 4r upon 3 pi. This is not x bar. This is just 4r upon 3 pi. The distance of the centroid from the radii is always 4r upon 3 pi. So here, I want to write x3 bar. It is going to be 2a minus 4r. What's the radius? It is a. So 4a upon 3 pi. I will need to calculate this value, students. I will have to find this value x3 bar. So let's get all the calculations a little while later. First, we will get all the values over there, and then we will do the simplification, the calculation part a little later. Let's get y3 bar also. Y3 bar is very simple. It is straight away 4r upon 3 pi, isn't it? This was the distance from the radius, and the radius itself is lying on the x-axis. So directly y3 bar is how much? It is going to be 4r upon 3 pi. So I write here y3 bar as 4r upon 3 pi, but the radius is a. So that's simply 4a upon 3 pi. So that's the quarter circle, the first one, isn't it? This was the first quarter circle. Now let's take the second quarter circle, which is over here, isn't it? So let's shade this region. This is the second quarter circle that I want to think about. I want to do the calculations. This is the second quarter circle. Now look at its position. Look at the center of the quarter circle. It is at a distance of 2a and 2a from the x and the y axis. So this is where you should be drawing the quarter circle, students. You draw a very big square if you want, which is 2a and 2a the sides. Then you get this particular corner, and from this corner you draw a quarter circle. So let's begin with the fourth diagram. The fourth diagram is again a quarter circle, isn't it? The fourth diagram is again a quarter circle. So this time I'm going to draw this very big square, and then I'm going to draw this quarter circle at one of its corner with the side or the radius being a, isn't it? So let's take this diagram. So I draw the x-axis. Make sure that you mention capital X and capital Y. You draw the bigger square. The total distance over here is 2a, isn't it? This is 2a, and this distance is also 2a. So that's 2a and 2a, isn't it? The distances are 2a and 2a. Now let's draw a quarter circle such that the radius has to be a, so it will be definitely at the midpoint over here, isn't it? So let's draw the quarter circle. So I'm going to draw this quarter circle over here. Remember, the diagram is only for a representational purpose. It might not be according to the scale. This has to be always remembered. So that's your quarter circle, isn't it? Now I know that the centroid of the quarter circle is definitely going to lie at distances 4r upon 3 pi from the two radii. So what you do is you draw lines which are parallel to the radii. They both intersect, isn't it? Such that the distance from the radii is how much? This distance is 4r upon 3 pi, and this distance is also 4r upon 3 pi, isn't it? The distances should be 4r upon 3 pi. Now, these distances are 4r upon 3 pi. This is the centroid. I call it as G4. Are these distances x bar and y bar, students? They are not x bar and y bar for the quarter circle, isn't it? X bar is the distance of the centroid from the y-axis. This is where your y-axis is. This is the centroid, and this is 4r upon 3 pi, which is not the distance of the centroid from the y-axis. That means you need to draw the distance over here. So let's draw the distance. Let's draw perpendicular from the centroid on the y-axis, isn't it? So this is the distance of the centroid from the y-axis. This is going to be x4 bar, and likewise students, its distance from the x-axis is going to be y4 bar. Both the distances are not 4r upon 3 pi, but can you say that both the distances are going to be how much? This total length is 2a. So from this 2a, if you remove 4r upon 3 pi, you will get x4 bar, and again from the distance 2a, you remove 4r upon 3 pi, you will get y4 bar. So here, first of all, I'm going to write the area. Students, what is the area going to be? It is very simple. So area A4 is again going to be pi r square by 4, because it's a quarter circle, isn't it? The radius is a, so it is again going to be pi a square upon 4. So that is the area A4. Now let's very quickly find x4 bar and y4 bar. So x4 bar here is equal to total distance is 2a minus 4r upon 3 pi, isn't it? So that's 2a minus 4, radius is a upon 3 pi. So again I will need to get this calculation. That's 2a minus 4r, radius is a, 4a upon 3 pi, and I should be getting y4 bar also, students, here. Y4 bar is also going to be 2a minus 4r upon 3 pi. A is again the radius, isn't it? So the value of r has to be taken as a. So both x4 bar and y4 bar are what values? It is 2a minus 4a upon 3 pi. Now I've got the coordinates of the centroid for the quarter circle. The second one, this was the second quarter circle, isn't it? So I'm going to write here, this is the second quarter circle. And finally, students, I'm going to take the third quarter circle now. You can observe that this is the third quarter circle, isn't it? So let's shade this part also. This is the third quarter circle, and this quarter circle also needs to be removed from the entire shape, isn't it? We already have removed this part, isn't it? This was the square plate, the square lamina, isn't it? This square lamina has been already removed from the entire square plate, a very big square plate. So now I need to focus on the third quarter circle. Look at the position of the third quarter circle again. It is having its center over here on the y-axis. The distance is 2a, isn't it? So let's draw the final diagram, the fifth quarter circle, the third quarter circle, the fifth standard shape. The fifth standard shape, again, it is a quarter circle, isn't it? So I take the x and the y-axis. This is the x-axis, and this is the y-axis. Now I need to draw the quarter circle where its radius, one of its radius is along the y-axis. You can observe here. So one of the radius must be at the y-axis. So here it was 2a. So let's draw a quarter circle. Again, I am telling you that the diagram is only for a representational purpose. Remember, the diagrams are made only to understand the exact position. That's all. The dimensions may not be in the exact way. So here the radius is again how much? The radius is again a, isn't it? So it's a quarter circle. Its centroid is again going to lie at the same distance 4r upon 3 pi from the two radii. So you draw the two lines which are at a distance of 4r upon 3 pi. So this is 4r upon 3 pi distance, and this distance is also going to be 4r upon 3 pi, isn't it? Both the distances is going to be 4r upon 3 pi. This is the centroid. I call this as G5, isn't it? That's the centroid G5. Now, you need to again tell me the distance of the centroid from the original y-axis and the x-axis. It becomes x bar and y bar. So, if you observe, this is G5. I draw the horizontal distance here. This is going to be x5 bar, and the vertical distance is going to be y5 bar. So, you can clearly understand that this x5 bar is same as 4r upon 3 3 pi. X5 bar is same as 4r upon 3 pi, but Y5 bar is not 4r upon 3 pi. You know that this total distance was how much? This total distance is 2a, isn't it? If the total distance is 2a, from the total distance, if I remove this 4r upon 3 pi, I will be getting the rest of the distance, which is Y5 bar. So students, again, very quickly, let's get the area first of all. So that's A5. It is again going to be pi r square upon 4. So it is pi a square upon 4 because the radius is again a. Then let's get x5 bar. You can easily understand that x5 bar is going to be how much? x5 bar is straight away 4r upon 3 pi, isn't it? So it is directly 4r upon 3 pi. Radius is a. So x5 bar is 4a upon 3 pi, isn't it? And finally, students, I want to get y5 bar also. So look at y5 bar. It is going to be the total distance, which is 2a minus 4r upon 3 pi. So I write here y5 bar as 2a minus 4a upon 3 pi. So I will definitely need to find the answer over here. I'm going to get this answer for y5 bar. So let's write it over here. The values of x4 bar, y4 bar over here, y5 bar over here, isn't it? And then students, now finally I know if all the standard shapes are done. Now if I want to get x bar and y bar, we have the formula. What is x bar given by? X bar is summation of ai into xi upon summation of ai, and y bar is going to be summation of ai into yi upon summation of ai. So for both x bar and y bar, I will need the value of what? Summation of ai. So let's quickly get the value of summation of ai first. So I'm going to write the value of a as a1 minus a2 minus a3 minus a4 and minus a5, because I know from the very big square I want to remove the smaller square and the 3/4 circles. That means all the areas are going to be negative except a1. So I can write here summation of ai. Let's get summation of ai here. So summation of ai is going to be a1 minus a2 minus a3 minus a4 and minus a5. So what's the value of a1, students? We have the value of a1 is 4a square. Value of a1 is 4a square minus value of a2, it is a square. Then minus of a3. So a3 value is pi a square upon 4. Pi a square upon 4. Then the value of a4 is also pi a square upon 4, and the value of a5 is also pi a square upon 4. So I write here minus of pi a square upon 4. So it simply becomes 4a square minus 3a square. That's 3a square minus, students, 3a square minus pi a square upon 4 has come 3 times. So that is going to become 3 pi a square upon 4. So you can definitely take out a square common from here, and it is 3 minus 3 pi upon 4, or you can say you can take out 3 common, isn't it? A square common, you get 1 minus pi upon 4. Getting or not? I have taken 3 also common. It was 3 minus 3 pi upon 4. So 3 is taken out common, you get 1 minus pi upon 4 a square. So let's quickly get this value of 3 into 1 minus pi by 4, taking the help of a calculator. So I have this 3 multiplies with 1 minus pi upon 4, isn't it? So the value comes here 0.6438. So I'm going to write the answer as 0.6438, 0.6438 a square. So that's the summation of all the areas. Also, students, I want to get some more values, isn't it? So over here x2 bar, y2 bar was simply a upon 2. Here x3 bar is 2a minus 4a upon 3 pi. Again, a can be taken out common. You get 2 minus 4 upon 3 pi. So let's do that value also. 2 minus, you have 4 upon 3 pi. So let me do that calculation. 2 minus, you have 4 upon 3 pi. Getting or not? So the value that is going to come is 1.57558. So I'm going to write my answer here. So my answer is 1.57558 can be written as 5, 6, a was taken out common, so I write here a. This you need not do the calculation. Even if you want, you can do it. 4 upon 3 pi. Let's do 4 upon 3 pi also. So 4 gets divided by 3 pi. So your answer comes 0.42441318 and so on. So you can write 4 upon 3 pi as how much? It can be written as 0.4244 a, isn't it? So that's y3 bar. So let's repeat these values for the other terms, x4 bar, y4 bar and so on. So x4 bar and y4 bar, both the values are same, isn't it? x4 bar and y4 bar, both of them are 2a minus 4a upon 3 pi. So both the values are going to become 1.5756a. So both the values are 1.5756a. Both the values of x4 bar as well as y4 bar is 1.5756a. Let's move further for x5 bar. So x5 bar, it is 4a upon 3 pi. So I have done the value of 4a upon 3 pi. It was 0.4244a. So I write here 0.4244a. And finally, the value of y5 bar, students. So y5 bar is going to be how much? 2a minus 4a upon 3 pi. So 2a minus 4a upon 3 pi is 1.5756a. So I write here 1.5756a, isn't it? So I've got all the values of areas and x bar and y bar. So once I've got the values of area, x bar, y bar, now I'm in a position to find x bar, y bar for the entire composite shape, isn't it? So I know that the formula for x bar, so let's get here, x bar is going to be summation of ai into xi upon summation of ai, isn't it? So that's going to be a1 into x1 bar. So a1 is 4a square into x1 bar, which is a here. So I get 4a square into a. Then all the next areas are going to be negative. Every area that you are going to get is going to be negative. So minus of a square into a upon 2. So minus of a square into a upon 2. That's the second one, isn't it? A square into a upon 2. Then the third one, it is pi a square upon 4. So I write minus of pi a square upon 4. That's the area. It multiplies with x3 bar, 1.5756a. So the calculations are going to be slightly difficult over here, slightly challenging over here. So we need to take care of all the values. 5756a, isn't it? That was a3 into x3 bar. Next one is again going to be negative side, isn't it? Minus pi a square upon 4 minus of pi a square upon 4. This area multiplies with x4 bar, which is 1.5756a. So I write here 1.5756a. Then minus sign again, students. So let's write over here minus sign a5. It is again pi a square upon 4. So I write here pi a square upon 4. That's the area. It multiplies with x5 bar. So the value of x5 bar is 0.4244a, isn't it? So this is all summation of ai into xi. This needs to get divided by the value of summation of ai. Summation of ai, if you see, the value has come 0.6438a square. So I'm going to write here 0.6438 a square. Now let's finally get the answer over here. You can observe that this is a square into a square into a square into a. Everywhere you find the same value, a square into a. So this a square into a is going to become what? It is going to become a cube, isn't it? So you simply need to multiply the numbers, students. Just multiply the coefficients of a. That's all you need to do. You will take out a cube common. Now once you take out a cube common from the numerator, you can see a square is present in the denominator. So a cube in the numerator, a square in the denominator, it will cancel and you get your answer as a. So you simply need to add and subtract the coefficients of a. That's all, nothing else you want to do. So let's carry out that simplification. Again, I will need the help of a calculator. So what I'm going to do here is, from every single term I have taken out a cube common. So that must be in your mind. You keep this point in your mind that a cube has been taken out common. A cube from the numerator, a square in the denominator, it is going to get cancelled and you will be only left with small a. Now let's take the coefficients. Let's take the numbers of all the coefficients of a cube and do the calculation. So again, I will need the help of a calculator. I'm going to make use of a calculator over here. So what's my first value? The first value is 4. You have to be very attentive over here. You make use of a calculator, do your own calculations as well simultaneously. So just be very careful with the numbers. That's all. So the very first value is 4. Then there was a cube, so just forget it. There is 1 into 1 by 2, so that's 1 by 2. 1 by 2 is 0.5, so 4 minus 0.5. Then next value minus there is pi by 4, 1.5756, pi by 4, 1.5756. 2 times it has come. So I'm going to write 2 into pi upon 4, isn't it? This 2 is for what? There are 2 terms. So 2 into pi by 4 into 1.5756. A is completely ignored, isn't it? A cube has been taken out common. And then minus, students, the next value pi by 4 into, so I will write pi upon 4 multiplies with 0.4244. That is entire numerator, isn't it? So I will get some answer over there, and this answer needs to be divided with 0.6438. So your answer comes 1.074449. So I'm going to write my answer for x bar as 1.0744 5 times of a. Why this a has come, students? Because in the numerator there was a cube and in the denominator there was a square. So this all calculation that I've done is for x bar. This is capital X bar. I still need to shift the origin, but that I'll do a little later. So that was x bar, students. Now let's get y bar. Let's very quickly get y bar. So here, if I do the calculation for y bar, it is going to be summation of ai yi upon summation of ai. So let's write all the calculations very quickly. So that is a1, which is 2a square, 4a square. So I write here 4a square multiplies with y1 bar, which is a, then a minus sign. The next area, which is a square, it multiplies with a upon 2 y2 bar, isn't it? Be very careful. Then the next area, a3, that is pi a square upon 4, so minus of pi a square upon 4. This multiplies with what? This multiplies with y3 bar, which is 0.4244a, 0.4244a, then a minus sign again. The next area is a 4 pi a square upon 4 multiplies with 1.5756a. So that's pi a square by 4 multiplies with 1.5756a, and this again finally the last value is a5, which is pi a square by 4, and y5 bar again it is 1.5756a. So here you get pi a square by 4 multiplies with 1.5756a, and this entire answer also needs to be divided by summation of ai, which was 0.6438 a square. So you can observe that this entire thing that you have got is an exact copy of x bar. 4a square into a, 4a square into a, then a square into a upon 2, a square into a upon 2. You have pi a square by 4 into the 0.4244a. It is present at the end over here, and these two values are again repeating over here also. So it is an exact same calculation. Observe, students, look at this entire diagram. Can you say that this entire diagram is symmetric about this particular line? Observe carefully. This is the line of symmetry for the composite shape, isn't it? It is line of symmetry for the composite shape. So wherever the centroid lies, the centroid will be at an exact distance from the x and the y axis. That is the reason x bar and y bar have come exactly same. So here my answer is going to be 1.07445a. But you got to understand the values that you have got are for capital X bar and capital Y bar, isn't it? So you need to again shift the origin. So can you tell me the old coordinates of the new origin, students? Be very careful when you tell the old coordinates of the new origin. The new coordinates of the new origin is definitely 0, 0, but the old coordinates with respect to the original x and the y axis. So this is your x axis, this is your y axis. With respect to the x-axis, with respect to the y-axis, you can find that the new origin is present in the third quadrant. And what are the distances? A and A. So I can say the coordinates, the old coordinates of the new origin is going to be minus A, isn't it? Now students, if it is minus A, this value minus A is the value of H is minus A, and K is also minus A. So both H and K are minus A. Now don't you know that small x will become equal to capital X plus H, isn't it? And small y is going to be capital Y plus K. Now you tell me what is x bar here? The value of x bar, y bar, both of them have come same. H and K, both of them are same. So both the values are going to be same, isn't it? Both the values are going to be same. So let's get both the values together. So x bar or y bar, you take it is 1.07445A. So 1.07445A minus what is H and K? A, isn't it? Minus A. So plus H plus K, it is minus A. So that's minus A. So you simply need to subtract A from here, 1A. So 1.07445A minus A will give me what answer? It gives me 0.07445A. 0.07445A. It is both small x bar as well as small y bar. So students, in this question also we have seen the concept of shift of origin. Always remember, if you shift the origin for some particular questions, the question becomes slightly easier, but for that you need to know the concept of shift of origin. So students, I guess these two questions are more than enough to understand the concept of shift of origin. Otherwise, I have only made use of the concept of the centroids of the standard shapes. So that was all about this particular question. Now we will proceed ahead with some more questions.